After completing this lesson, you'll be able to understand revisions, create a new revision, and work with revision clouds. The objective domains covered are 3.4a, Understand Sheet Issues Revisions, 3.4b, Create a Revision, and 4.2a, Develop and Customize Schedules. When changes are made to a drawing and the drawing has been released, you should create a revision and log this in a revision table. The changes to the drawing sheet can be indicated with a revision cloud and a revision tag. You can either control the revisions globally in a project or per sheet. This has to be decided before any revisions are created. Go ahead and open up the model 031 working with revisions. The model opens up in the sheet view S00502 still framing. Most sheets in drawings will contain revisions, and you can see here we have a revision table that's embedded in the drawing sheet. Also, the drawing sheet here will report on the current revision. Revit's revisioning system allows us to create revisions per project or per sheet. Let's take a look at these revision settings. On the View ribbon, select Revisions. In the Sheet Issues Revisions dialog box, you can see one row has been added, and this is the first issue. You'll notice that the numbering is alphanumeric. We have some options here. We can have numeric, alphanumeric, or none. Then we have the date, description, whether it was issued or not, the issued to, and issued by. In this case, I'm going to issue this. Now, when we do this, you can see then that we can't make any edits or changes to that revision because, of course, the drawings have been issued out. Let's also take a look at the numbering. So you can see here, as we've just discussed, the numbering can be set up per project or per sheet. Most projects require you to do this per sheet because different sheets may have different revisions. You may issue one set of drawings but not another set from the same project. A bit further down, you can see we have our numbering options. In this particular project, I'm using alphanumeric, and you can see here that we can then derive a sequence for our alphanumeric numbering. So I'm starting off with a dash, and then we're going through A, B, C, D, and so on. And of course, you'll notice here, if we want to, we can remove letters such as I or perhaps O from the revision sequence. And then here we have an option to set an arc length. So when we create a revision cloud, it will use the arc length specified here. Okay, let's go ahead and add a new revision. So I'm going to click on Add. And our intention here is we've moved this wall, this blockwork wall, and we need to add a revision and mark the drawing as such. So here we can set a date. So we'll have that a day after the original change. We can then put a description in. So here I'm going to say moved blockwork wall 6 inches to right. And here you can see the show is set to cloud and tag. So let's go ahead and say OK. And if we look at the revision schedule, we'll see that we're still on first issue. In order to get this new revision to appear in our revision schedule, we must cloud it. So we'll zoom into the element that's changed, which is this blockwork wall here. We'll select the Annotate ribbon and select Revision Cloud. In the Properties palette, we have something called a sequence, and this is where you decide what revision your cloud refers to. So here it's going to refer to the revision we've just created, which is Move Blockwork Wall. On the Context ribbon, you can see that we can decide on the type of geometry we're creating for our revision cloud. In this case, it will be a simple rectangle, and we'll then cloud around the wall or the element that's changed. Let's go ahead and select Finish Edit Mode. So the revision cloud is now created, and if we take a look at the revision table, you can see that it's added our new revision through. Also, if we have a look at the current revision on the sheet, it's now changed to Revision A. When working with a number of sheets and revisions, it can be quite useful to see these in a tabular format. So we can create a schedule from these. On the View ribbon, select Schedules pull down, and then click Sheet List. In the Sheet List Properties dialog box, I can take the available fields on the left and add them across to the scheduled fields on the right. So I'm going to begin here by taking in the sheet number, the sheet name. We'll then take the current revision, the current revision date, and then when it's been issued. I can then click OK, and you can now see that we have our sheet list. Now from this sheet list here, it's very easy to filter the schedule based on whether the sheets have been issued or not. Also, I can very clearly see the revisions and what state they're at. If I want to, I can now open up another sheet, such as this one here, and then of course I can drag and drop that sheet list directly onto the drawing sheet, and that can form part of the drawing package. After completing this lesson, you will be able to understand sheets, understand browser organization, apply browser organization to sheets, and use guide grids. The objective domains covered are 4.1a, understand browser organization, and 4.1f, set up a sheet. Sheets are an integral part of design communication and are a vessel for construction and design data. A sheet is a Revit family which can be customized and edited to suit project requirements. Guide grids can be displayed to keep view positions neat and consistent. Larger projects can contain a significant number of documents, so good management of views and sheets is an essential skill for efficient working. Project views, schedules and sheets can each have different sorting and filtering applied in the project browser. Go ahead and open up the file 032 Setting up and Managing Sheets. The project opens up in the 3D view. Our first task is to create a new sheet and then add a material takeoff to that sheet. To create a new sheet, select View and then select Sheet. In the New Sheets dialog box, select B11 by 17 horizontal and then go ahead and select OK. A new sheet is now created. In the Properties palette under Identity Data, you'll note here that we have properties such as sheet number and sheet name. We can use these properties to fit out the title block. So here I'm going to change this to Material Takeoff. And you can now see the sheet is filled in. We'll now add our material takeoff to this particular sheet. In the project browser, under Schedules Quantities, you'll note here we have a folder for materials, and here we have material takeoff. Let's drag and drop that material takeoff onto our drawing sheet. In the project browser, you'll note that we have a number of sheets already set up with views. This is easily identified by looking at the plus sign. You'll notice here that we have two sheets currently without views. We have S012 and S013. Let's go ahead and open up S012. You'll note here that this sheet is a placeholder for the second floor GA plan. In the project browser, you'll notice here that we have the second floor plan. But you'll also notice that here we can see views not on sheet. This is the browser organization, and I've set the browser organization up only to display views that currently haven't been positioned on a sheet. To do this, you could right mouse click over the browser organization node and then select browser organization. If I select all and select OK, you'll now notice that all the views are displayed in the project browser. But once again, if I right click over the top node here and select browser organization, here I'm going to say not on sheets. So let's now go ahead and place our second floor plan onto the sheet. We'll do the same for our fourth floor GA plan, so go ahead and open up the sheet S013, locate the 04 fourth floor plan, and again drag and drop that onto the drawing sheet. Okay, we now have these two sheets created and set up, but you'll notice as I toggle through them, the positioning on the sheet isn't consistent. It'd be quite nice to have these views consistently placed. To assist us with this, we have something called a guide grid that we can use. On the View ribbon, select Guide Grid. We can give this guide grid a name, so I'm going to type in here, Plan Views, and click OK. You'll now notice that a guide grid is displayed. I can select the guide grid And then in the properties palette, I can change the grid spacing. So here, I'm going to set this to 6 inches. You'll notice here that we have an intersection on the guide grid. And what I could do is I could move my drawing view to match up with grid 1A on the intersection. So let's go ahead and do that. So we'll make sure that we select our viewport. We'll select Move on the context ribbon. And we can then move our view from the intersection of the grid to the intersection of the guide grid. And that view is now precisely positioned on the guide grid. If we open up the second floor plan, here we can now use the same guide grid. So once again, on the View ribbon, select Guide Grid. You'll notice here we have our same Plan Views guide grid. We'll click OK, and the guide grid again is displayed. In a similar fashion, I can select our viewport, I can select Move, and I'll snap this to the guide grid. We now have completely consistent placing for both of our drawing sheets. Also note, of course, that the guide grid will not print. If you do want to switch the visibility of the guide grid off, we can go into Visibility Graphic Overrides. And under Annotation Categories tab, we can search for guide grid, and of course we can switch the visibility of guide grids off. Finally, we set up browser organisation for our sheets. You'll notice currently our active view is S012 second floor GA. In the Properties palette under Title text here, you'll see that we have something called Sheet Type. And if we go to the drop-down menu here, let's select Plans for that sheet type. We'll do the same for S013. So once again in the Properties palette for Sheet Type, let's go ahead and again select Plans. The sheet type is a project parameter that I've created and I'm using to control browser organisation. Let's now set up the browser organisation for these sheets. In the project browser, right mouse click over the Sheets folder and select Browser Organisation. Under Browser Organisation, note that we're currently in the Sheets tab. By default, all the sheets are shown. You can see here that we have some defaults that we can utilise. For example, I could choose Issue Date and select Apply. And you can now see in the project browser, the sheets are organised by their issue date. Notice that when I do this, it's only controlling the sheets. Everything else is left unchanged. What we need to do here is create a new browser organisation. So go ahead and select New. Here, I'll name the browser organisation Sheet Type. And then select OK. In the Browser Organisation Properties dialog box, the first tab is to filter unwanted views. So for example, when we looked at the views not on sheet, we were filtering that by views not on sheets. However, here we want to utilise grouping and sorting. You can see here we have group by, and here I can select my sheet type. And then I'll organise it by the sheet number. Let's go ahead and select OK. We'll ensure that sheet type is the active browser organisation and then select OK. You'll now notice that our sheets are organised into folders. For example, here we have elevations and also plans. Also note here we have a folder with some question marks. This will be a sheet that currently has no classification. For example, here if I select the sheet Material Takeoff, you'll note in the Properties palette, the sheet type hasn't currently been configured. So once again, I can set this to List and Schedules, and you can now see it's automatically grouped into that folder. So particularly useful for larger projects with lots and lots of sheets. After completing this lesson, you'll be able to understand phases, work with phases, and set phase and phase filters. The objective domains covered are 3.3a, Use Phase Filters. Construction phasing is very important to help understand the correct sequence of construction, the required materials, and various different assets that are required. Revit can create construction phases and assign elements and parts to each phase. Documentation can then be produced to show each phase. Phase filters and graphic overrides control how the differing phases appear in each drawing view. Go ahead and open up the model 033 working with phases. The model opens up in a 3D view. This particular 3D view that we're looking at the minute has a section box applied. So I've used a section box to hide all the levels above that currently don't have a phase associated with elements or parts. All of the elements and parts we see in the screen here have phases applied. So for example, if I select this tunnel here, you can see in the properties palette that we have a phase created, which is 0, existing tunnel, and it's not demolished. Let's have a look at another example. Let's select this floor slab here. And once again, you'll see the phase created here is phase 10, and again, it's not demolished. So all of these elements have phases assigned to them. Currently now we don't have a selection set applied, so the properties palette is displaying the properties of the active view. So of course you'll see that we have things such as view scale, detail level, and so on. Right down the bottom of the properties palette we have phasing, and you'll notice here that we have current active phase, phase 1, piling. However, the display doesn't look any different, and the reason for this is because we have no phase filters currently operational. Let's now set a phase filter. So here I'm going to ask Revit to show anything that's newly constructed and its previous phase. So of course you'll see here that the newly constructed items, which are the piles, are shown in blue and the previous phase is shown in grey. Let's now change the active phase. So the active phase now is phase 1. Let's now have a look at phase 2. And of course you'll now see at phase 2 we can see the slabs cast, but of course now the piles and the tunnel are on the previous phase. Let's jump ahead and perhaps look at 4A, steel columns. So again here you can see we have some kickers cast and also our steel columns erected here, but everything else is in a previous phase. So let's now take a look at the setup of these phases. Select the Manage ribbon, and here you'll notice we have phases. Let's go ahead and select phases. The phasing dialog box opens, and you'll note here we have 3 tabs: project phases, phase filters, and graphic overrides. So the project phases are showing me all of the phases that I've set up in this active project. For example, if I'd like to add another one in here, perhaps phase 14, you'll notice here we can insert after or before the selection set. So here I could insert a new one, and in here I can just type in a name. So in here we might have first floor kickers, and we can also then present a description for this as well. So I could just copy and paste perhaps in there and click OK, and then that would create that new phase. I could then assign that to different elements in the project. The next tab we can look at is phase filters. So you'll see here that we've only currently got 2 phase filters in this particular project. I either show everything if nothing is overridden, or here I can show a newly built object and the previous phase. Now you'll note here with this example we have show new and previous, so the new object is overridden, the previous set elements are also overridden, anything that's demolished or is a temporary structure is currently not displayed. Finally, let's select graphic overrides. So here we have those phase statuses. So you can see here we have the existing status currently in line work, that's going to show as grey, and you can see it's using the material here phase existing. This particular material I've made grey. You can then see we have our new phase, and in here I've overridden this to appear blue, and again the material is set to phase new, and I've created the material here again to be blue. Let's now have a look at creating a new phase filter. So perhaps what I want to do, rather than actually seeing the existing objects that have previously constructed in previous phases, I might just want to isolate the newly built components. So let's go ahead here and create a new phase filter. So here we can type in show new. So newly created objects, we're going to use the overridden style. So you may remember that's going to appear shaded in blue. And also if I use a hidden line, it will come out in a blue hidden line outline. Existing phases are not displayed. Demolished is not displayed. And temporary is not displayed. Let's go ahead and select OK to our phasing dialog box. And now you'll notice in all of the views, if I go to phase filters, I have that new phase filter, show new. And of course here, it will only display newly created elements. So let's now step through some more phases. So if we go to phase 4, which is the column base plates, here I just get displayed the column base plate itself. Let's go back and look at the basement walls. So again here I can see my grade beams and my pile caps and the kickers for the columns. Finally, when creating documentation of your phases, you'll need to duplicate the views and then create new phase filters. So for example here you can see that I have a view 3D phase model. I'm going to go ahead and rename this and I'll call this one phase 3. We'll then go ahead and duplicate this view, and here I can rename this one. Let's call this one phase 2. Okay, so for the properties of our new view phase 2, we can set the phase to phase 2, and then finally we'll duplicate again, and here we'll rename this one and we'll call this phase 1. And of course, we'll set our active phase in the properties palette to phase 1. So if we want to present these onto some drawing sheets now, of course, we can come down to our sheet list and you'll see here, for example, I've got a sheet phase 1 build. And we can then drag and drop our 3D view phase 1 onto the drawing sheet. Now, of course, when we create schedules, we can also incorporate a phase in our schedule. So you notice here that I have a schedule set up for our phase 1 materials, and of course I can then position that on the same drawing sheet. So this just tells me we need concrete and this much concrete for this particular construction phase. Let's do one more. So let's go ahead and open up phase 2 build. So again, I can go and find my phase 2 3D model, drag and drop this onto the drawing sheet. Then we can go and find our phase 2 material takeoff and again position that one onto the drawing sheet. And of course, once again, if we wanted to see previous phases within our drawing, we can select the view. And of course, we can now change our phase filter to the previous one we had, which was show new phase and previous construction. After completing this lesson, you'll be able to understand design options, apply design options to duplicated views, and set a primary option. The objective domains covered are 3.3, assign, display, and accept primary design options. Design options are essential in early design when evaluating different structural arrangements prior to committing to a preferred design option. Design options within Revit facilitate these requirements, allowing the development of numerous options and then the final selection of the preferred solution. Go ahead and open up the model 034 working with design options. The model opens up in the 3D view. In this particular example, we're going to have a look at two different designs for the front of our building structure. Here you'll see that we have a steelwork design primarily showing rolled curved members across the front of the structure. So let's now have a look at some different design options. On the Manage ribbon, you'll note here under Design Options we have an Active Design Options menu, and here we have two options. We have our curved steelwork, which is our primary preferred option, or we have a second option, faceted steelwork. The Active Design Options menu can also be activated from the status bar. You'll note here that we have the same functionality. Let's first have a look at how we set up design options. So again, on the Manage ribbon, you'll note we have Design Options. Let's select Design Options. And you'll see here first, we have something called a option set. So of course, there could be several options around the whole building structure. We may have an option for different roofing. We may have another option for the front of our building structure, another option for foundations. So the option set contains the options. Once we've created an option set, we can create individual options within that set. One of the options would always be a primary option, which is the preferred option. When presenting options to clients or stakeholders, it's quite useful to be able to present these on drawing sheets. So what we're now going to do is duplicate our 3D view and then present both options on the drawing sheet. In the project browser, right mouse click over the 3D view and duplicate. I'm going to rename this, and this one will be Reception Option 1. And again, I'll duplicate that view again. And this will be Reception Option 2. Okay, so I have my two duplicate views. To set the option active in the view, we first need to go into Visibility Graphics. To do this, select the View ribbon and then select Visibility Graphics. When design options are active within a model, you'll notice we get a new tab, Design Options. And in the Design Options, you'll note here that we have our design options set, and then we can decide which one we want to present. So in this case here, for option 2, this is going to be the faceted steelwork, and I can then go ahead and say OK. Let's now open up Reception Option 1. And again, we can go to Visibility Graphics, select Design Options tab, and here, select Option 1. So we now have two views that allow us to present each option to stakeholders or clients. Of course, these options can be added to a drawing sheet, so we could simply take one of our options and drag and drop them onto the relevant drawing sheets. If we wanted to present them side by side, of course, we could present both options on the same drawing sheet. Let's return back to our main 3D view. Now, once a stakeholder or client has decided the preferred option, we'll then need to accept that as the primary option. To do this, we can go back to the Manage ribbon and select Design Options. Our option set, Entrance Steelwork, contains two options. Currently, the curved steelwork is the primary option. If this is the one the client accepted, we can simply say Accept Primary. The following dialog box is saying that the remaining option sets will be deleted from the model. It's recommended to save a backup of this model just in case the customer or client or stakeholders change their mind. But in this case, I'm going to say yes. I'm going to accept the deletion of the view that's carrying option 2. And then go ahead and select Close. After completing this lesson, you'll be able to understand work sharing and work in a collaborative environment. The objective domains covered are 4.1G, Apply Work Sharing Display Modes to a View, and 5.2A, Understand why work sharing features are used. In larger projects, several team members may need to work together or collaborate within the same Revit project. Work sharing enables multiple users to access the same Revit project and file. You can use a local area network or a wide area network system or collaborate on the cloud. When collaboration is enabled, you can divide the project into work sets. For example, you may split the model into steelwork and concrete, or perhaps down movement joints. Careful consideration should be given to how a model is divided into work sets. Perhaps by level and structure type, in this case the roofing steelwork and skybridge. Or perhaps by structural movement joints, in this case the west wing of the structure. Go ahead and open up the model 035 using work sharing features. Ensure that you open this from the folder 035 Central Model. The model opens up in the 3D view. Our first task is to enable work sharing. To enable work sharing, select the Collaborate ribbon, and on the Collaborate ribbon, select Collaborate. In the Collaborate dialog box, you have two options. You can collaborate within your own network using a local area network or a wide area network, or you can collaborate on the cloud with BIM 360 Document Management. In our example, we're going to select within your network. Go ahead and select OK. Work sharing has now been enabled. You'll now note that Work Sets is active on the ribbon. Let's go ahead and set up some work sets. Select the work sets command and you're presented with the work set dialog box. By default, two work sets are created, shared levels and grids and work set 1. So the levels and grids are automatically added to shared levels and grids and everything else is on work set 1. We're going to create some new work sets. Go ahead and select new. Here we can name our work set. So we'll start here by creating a work set for the east wing. And then select OK. We'll create another work set for the roofing steel. And another one for the west wing. Go ahead and select OK to the work sets dialog box. You may be prompted to make the last work set active. In our case, we'll say no. Each element within the model can now be assigned the relevant work set. First, we're going to record some selection sets. On the Manage ribbon, click Load Selection. Let's begin with East Wing. We'll select East Wing and then click OK. Note in the Properties palette we have multiple categories selected, but the common property here is the work set. And here we can now select our relevant work set. So in this case, this is the East Wing. Now, of course, we may have openings going through different work sets here. So this is just warning us that the opening partially cuts its host. We'll go ahead and select OK. Let's go ahead and load the selection set for roofing steel. On the Manage ribbon, select Load Selection and select Roof Steelwork. Once again in the Properties palette, you'll note that we have multiple categories selected, but again here we can select our relevant work set. So in this case here, it's going to be Roof Steel. Finally here, we'll load the selection for the West Wing and then assign the relevant work set. Okay, so our work sets are now populated with the correct elements. To visually check that we have the correct elements on the correct work set, we can use Worksharing Display. On the View Control toolbar, select Worksharing Display and then select Work Sets. Each work set is now represented with a different colour. These colours can be reviewed or changed and edited. To do this, select Worksharing Display and then select Worksharing Display Settings. In the Worksharing Display Settings dialog, on the Work Sets tab, you'll note here that we can visually see each work set. If we want to change colours, we can select the colour, and of course we can select a new colour from the colour palette. Go ahead and select OK, and switch Worksharing Display off. We're now ready to create our central model. On the Quick Access toolbar, select Save. We are notified that this is the first time that the project has been saved since the Worksharing was enabled. This model will now become the central model. Normally, this would now be on a file server somewhere. Let's go ahead and select Yes. Notice on the Quick Access toolbar that the standard Save tool is now grey or inactive, and instead here we have Synchronize and Modify Settings. This is now the central file. And this is quite an easy way to visually see whether we're working in a local file or a central file. Go ahead and close down this file. Select File and then select Close. Each user now creates their own local file. To create the local file, select Open. Browse to the central model and select the central model. In the lower half of the dialog box, you'll note that Create New Local is already ticked, so we can go ahead and say Open. The local file is now open. The file name is the same as the original file name, underscore, and then the user's name. By default, when I save this, this will be saved into my documents. If we take a look on the Quick Access toolbar, we'll now see that we have two different saves. I have Save, which will save to my local file, or Synchronize and Modify Settings that will publish my changes up to the central model. I'm now going to relinquish all of my ownership of the work sets. To do this, select the Collaborate ribbon, and you'll note on the Collaborate ribbon I have a tool here, Relinquish All Mine. Just to show you what this is going to do, let's first select Work Sets. So you'll see that we have our various different work sets displayed in the Work Set dialog box, and you'll notice the owner is still myself. What I'm now going to do is relinquish the ownership of all of these elements. To do this, I can select Relinquish All Mine. And now, if I select Work Sets again, you'll now notice that I'm not the owner of any of these items. However, if I want to take ownership of shared levels and grids, I can now make that editable, and you can now see I have ownership of that work set. Let's go ahead and select OK. So now a colleague has opened up a session of Revit and also browsed to the same local file. So we're now going to see what happens when a colleague wants to edit a particular area of the model. So here they're going to select the roof, and you'll notice we have an icon attached to this element. If I select this icon, this will make the element editable. So now what happens if I also wanted to select and edit that same roof? Well, let's take a look. So now if I select the roof in my software, and then I select the icon, Make Element Editable, you'll notice that I get an error down here. This is essentially saying that I can't actually edit this until my colleague resaves it and relinquishes the element. Notice here, of course, I could place a request through to my colleague to show my intention that I did want to change this. However, I could have seen that my colleague had ownership on this by using my Worksharing display. Here, if I select Owners, I can now see that the roof is red. Now, this would all work in real time, so now we're going to switch back to my colleague, and we'll see my colleague take ownership of another element. So my colleague is now going to take ownership of this floor slab here. So once again, they can select that element and then select Make Element Editable. And now when I view my machine here, I can now see that that floor slab is also owned by my colleague. So now my colleague is going to go ahead and make a change to the roof slab here. He's simply going to change the pitch. So in the Properties palette, he makes a change of the roof to 12 degrees. My colleague then saves local and can then also save to central. Notice that we can also put a comment in for this change. And then select OK. Here, I'm going to now switch Worksharing display off. But you may notice that my roof doesn't appear to have changed. This is because I need to reload the latest changes. To do this, select the Collaborate ribbon, and you'll notice here I can reload latest. Note now that I can see the change to the roof slab. If I wanted to review the history of the central file, I could also do that. I could select Show History, then I could go ahead and pick the central file and select Open. And I can see very clearly here that my colleague has made a change and an edit to the model at this date and time, and has also added comments here. After completing this lesson, you'll be able to understand Revit warnings and export Revit warnings to a HTML file. The objective domains covered are 5.6c, Assess and Review Warnings in Revit. Revit may produce warnings within your project for a variety of different reasons. For example, you may have an element that is slightly off axis, an overlapping element, or a constraint conflict. Some of these errors can simply be ignored, but some must be resolved before you can proceed. However, you should try and resolve as many errors as possible to promote model health and keep the performance of the Revit model optimal. Go ahead and open up the model 036 Assessing and Reviewing Warnings in Revit. The model opens up in the 00 ground floor plan. Let's begin by having a look at what causes some errors inside Revit. You'll see here that we have a series of 3 reference planes modelled, and I have some aligned dimensions dimensioning the reference planes. The reference planes are all pinned. So consequently, if I select this string of dimensions and I toggle the constraints to be equal, you'll see that Revit produces an error. This particular error here is saying that constraints are not satisfied, and you'll notice here that I have to cancel this or remove the constraints before I can proceed. This type of error is relatively safe because you can't ignore it. You have to deal with it before you can move forwards within the model. However, other warnings can be easily ignored. For example, if I model a wall and then I model the same wall over the top of the original one, you can see I get a warning. But note here, if I press escape to come out of the wall command, I've now lost the warning dialog. I've now lost the ignorable warning. Some of these errors can be ignored, but others have to be resolved. Let's now review some of the warnings within this project. Select the Manage ribbon, and here you'll note we have Review Warnings. Let's select Review Warnings. So this dialog box here is now presenting all of the warnings, and you'll notice they're grouped together. So the first group we have here is beam or brace is slightly off axis and may cause inaccuracies. You'll note here that once this dialog box is open, most of the view commands will now work transparently with this dialog box. For example, I can open up and activate another view and then rotate and zoom and pan in this view whilst the dialog box is still open. So let's take a look at some of these errors in closer detail. So here I've just expanded this, and I can see here that this structural framing element is off axis. Now for an element to be off of axis, it could be as little as 10 to the minus 9 degrees off of axis, or up to a maximum of 0.2 degrees off of axis. Sometimes you can repair this just by dragging grips, but other times it's just easier to model the element again. Now what you'll find is, quite often on sloping roofs, it's quite common to get elements that are off axis. So some people would choose to ignore this, or you could try and resolve it by, as I've said, modelling it again. We'll come back to this one, but let's look at the next error. So you can see here we have identical instances in the same place. Of course, this is something you probably don't want to ignore. This can cause problems with the joining of geometry and also quantities of items. Not only just the double counting of a column, say, or a beam, for example, but of course it can give you more material than is actually required in the project. So let's have a look at this warning here. Again, we can click on show, or we can just rely on zooming around until we see the element. So you can see here, this is the problem. And if I select this next one here, I can see quite clearly that I have two elements over the top of each other. Notice here, of course, that I can actually go ahead and delete one of these elements. Now here I can actually see the element ID. So if I want to delete the very last one I modelled, that will be the one with the bigger element ID, which is this one here. So let's go ahead and delete checked. If we go back to review our warnings again, you can now see we've just got our beam and brace that's slightly off axis. And as I've said, I could just go ahead and remodel this again. If you're checking the model on someone else's behalf, or you're a CAD manager or BIM manager, it can be quite useful to be able to export all of these errors out and then present those to the people producing the models for resolution and repair. To do this, we can simply click Export. And you'll notice here the error report is exported as a HTML file. So let's go ahead and click Save. And the error report is now written out. Let's take a look at that report. So the report is now open, and we can clearly see our beam or brace is slightly off axis. And here it's telling us the section that's off axis and also giving us the element ID. Now here, of course, I can simply just copy that to the clipboard, and I'm now going to use this to go ahead and select that same element in my Revit model. So here we are in the Revit model. To select this element ID, select the Manage ribbon, and on the Manage ribbon, you'll note here we have Select by ID. I can now simply paste that into the dialog box and then click Show. And here's the beam that's off axis. After completing this lesson, you'll be able to understand interference checking and use interference checking for locating duplicate or overlapping elements. The objective domains covered are 5.6D, check and model for interferences. The interference check tool enables effective clash detection between selected categories. The clash check will identify intersecting elements and can produce a report. Most will use this tool to prevent double counting of elements or to find modelling errors. The interference check in Revit is limited to hard clashing, but other tools, such as Autodesk Navisworks, can be used for more comprehensive clashing. In the example on the right, Revit would not find an interference between the pipe and plate, so is normally not used for coordination between different disciplines. Go ahead and open up the model 037, checking the model for interferences. Let's begin by opening the interference check dialog box. On the Collaborate ribbon, select Interference Check, and then Run Interference Check. Here we're going to perform a check on the current project, but it is possible to clash between two different projects. Let's begin by checking for duplicate elements. So here I'm going to clash structural columns with structural columns. We can then go ahead and select OK, and you can see a clash is found. If we select one of these columns here and then select Show, you can see that Revit then zooms up on the clashing items, and I can clearly see there's a double count of columns here. Let's then select Close, and I can simply then go ahead and delete one of those columns. Okay, let's return back to interference check, and again we'll run the interference check, and this time I'm going to clash structural columns with structural framing. Again, let's select OK, and you can now see there are more interferences found. We can then expand one of these sets and select the relevant element and click Show. And you can see here we have a clash between the concrete column and a framing element underneath here. As that's concrete, that will just simply need to be joined together. Let's now have a look at some other clashing items. So here we'll select this structural column and click Show, and we can see here we have this round section, again clashing with this beam here. On closer inspection you can see it's a very small clash, and really this will be resolved with a structural connection. Once again, let's look at the next clash here. Again, that will be a very similar thing. This one here is a genuine clash though, because you can now see that we have a beam running right the way through the column. So of course there we could simply split the beam. So let's select Modify, and on the Modify ribbon we can use Split Element, and we could simply split that beam. So to summarise, the interference tool is very useful to actually find modelling errors and also duplicate objects within Revit. After completing this lesson, you will be able to understand the Audit tool and compact the central file. The objective domains covered are 5.6b, Understand and use the Audit and Compact tools. The Audit tool is used to maintain Revit model health, or to open and fix a model that ordinarily does not open. It is recommended to perform an audit periodically and for the reasons stated below: when upgrading a Revit model, when elements have become corrupt, or if the model is over 1 GB or greater than 1/20th of your available RAM. Central models can become very large, especially if the model division or level of detail is not managed correctly. It is useful to periodically select compact file when performing a synchronization on a central file, as this will reduce the file size. To perform an audit on a Revit file, the file cannot currently be open, so you need to close down the file and then select Open. In the Open dialog box, you can then select the Audit option. You'll then be warned that the audit could take a long time, so it's recommended to do this at the end of the working day. The dialog box also informs us that we should be auditing on a regular basis. It's recommended doing this weekly, especially when you have large models or corrupt files. So let's go ahead and select Yes, and we can then pick the model we'd like to audit. Now, when you audit a model, you won't get a report on the health of the model. It will simply just open it and then attempt to repair any corrupt files or problems. Also, you may find that it reduces the file size. Let's go ahead and select Open here. So the model's now opened up and been audited. As I've said, you won't receive a report on any issues here. Now, if the audit fails and you still can't recover a Revit model, then the next step is to go ahead and look at the journal file. So the journal file may indicate families that have been corrupt, and you can then get the element ID and search for that element ID and then delete the families that are causing corruption. You can then try and run the audit process again. Here I now have a central file open, and what I'd like to do here is compact the central file. It's useful to do this periodically, which will reduce the central file size. To do this, select the Collaborate ribbon and click Synchronize with Central. You can then go ahead and select Compact Central Model, but as indicated here, you can see that the synchronization and save will be much slower, but it will compact and reduce the file size of the central model. You can then go ahead and select OK. If you wanted to be able to compare file sizes and find out when the compaction happened, we could just simply type in here for the comment, compact central model, and then click OK. Okay, so the central file is now saved and been compacted. After completing this lesson, you'll be able to understand Purge and use the Purge command. The objective domains covered are 5.6a, Understand and Use Purge. When new Revit projects are started, there are many families and styles that are preloaded that may or may not be used. To reduce the file size and improve performance, you can perform a purge. It is recommended that you purge a file at the project completion. Go ahead and open up the model 039 using the Purge command. The model opens up in a 3D view. To start the Purge command, select the Manage ribbon and then select Purge Unused. In the Purge Unused dialog box, we can now see a list of all the views, families, and other styles that we might want to purge from the project. By default, all of the items are checked. So in the bottom of the dialog box, you can see in our case here, we have 627 items that are checked and can be purged. If I want to specify the items that I want to purge, I can say check none, in which case now we can see that 0 items are checked, and then we can be selective about the items we wish to remove. For example, I could open up the structural framing category, and you can see here I can't check these items because I've probably used some of the types from that family, but these 3 items here I could check and then remove. In this case, I'm going to select check all. Now, Purge is also capable of purging things like materials and appearances. Those elements cannot be purged until we've purged the families that may be referencing those. So let's go ahead and select OK. And we'll then go back and launch Purge Unused again. And you can now see we have much fewer items to be purged. But if you look at the bottom of the dialog box, there's still 32 items checked. And of course, as we just said, these are materials and assets. So now that we've removed the families that may be referencing these, we can then go ahead and purge these assets. And of course now we have a completely clean model. Let's now compare the file size. So here I'm going to save the project. You can just type perhaps purge afterwards. You'll notice that I've done a save as so I can compare the two. And we'll now compare the file size. And we can now see the difference between the two sizes. So here is our original file. And here is our purged file. After completing this lesson, you'll be able to understand object styles, understand line weights, line patterns and line styles, edit object styles, and create your own line patterns. The objective domains covered are 5.5, control the appearance of elements at a project level. Object styles are project-wide settings that control line weights, line styles, colours and materials for each category and subcategory. Typically, these settings will form the backbone of your Revit template. Line weights control the thickness of lines for model elements and annotations. Revit has 16 line thicknesses that can be used for model line weights, perspective line weights and annotation line weights. Model line weights can be assigned a thickness at given scale factors. For example, line weight 2 may appear thicker for 1 inch equals 1 foot than for 1/8 of an inch equals 1 foot. Line patterns are used to represent items such as hidden detail, centres and grid lines. Revit has several default line patterns and these can be edited to your requirements, or you can create your own patterns. The line patterns can consist of dots, spaces and lines. Line styles are a combination of line patterns, colour and line weights. They can be used for 2D annotations and are also used to represent other elements in Revit such as sketch lines. Typically, object styles, line weights, line patterns and line styles will be set up and stored in a Revit template file. Your new projects are then started from this template. Go ahead and open up the model 040, Editing Object Styles. The model opens up in the 5th floor plan. Let's start by investigating the Object Style dialog box. To do this, select the Manage ribbon and then select Object Styles. In the Object Styles dialog box, you'll note that we have 4 tabs across the top: Model Objects, Annotation Objects, Analytical Model Objects, and Imported Categories. Let's begin by taking a look at Model Objects. Now, of course, any changes we make in the Object Styles dialog box is project-wide. If we want to make a change to just one view, we would go ahead and use Visibility Graphic Overrides. Any changes we make in the Object Styles dialog box is project-wide, and generally this will be saved into a project template. Let's now take a closer look. For example, if we look at structural framing, we'll notice here that the projection line weight is using pen number 1, the cut line weight is using pen number 4, the line colour is black, the line pattern is solid, and you'll notice here that we have a default material applied. Let's now take a look at the subcategories of structural framing. So you'll see a lot of the default subcategories already being displayed here, but I've also created my own subcategory. This was created in a specific family, and you can see here that we have parapet framing. The projection is set to 1, however when we cut it, it uses a thinner pen, so this is set to 2. And what I'm going to do here is change the colour, perhaps to green, and change the line type to maybe dash. Now, like I've said, this is going to now be a global change to the project. So if I click OK here, straight away you'll see that the framing now turns green, but also if perhaps I open up the south elevation, the parapet is also shown in that dashed green line. So as you can see here, this is a global change. Okay, let's return back to our 5th floor plan. This time we'll make a change to some annotation. On the Manage ribbon, let's select Object Styles. And here we'll select Annotation Objects. Let's now make a change to the grids. So you can see here we have grid heads. So I'm going to change the pen weight perhaps to pen number 5. And I'll change the colour to red. And again here, this will now be a global change. So once again, if we switch back to the south elevation, you can see the grid heads in the south elevation have also undergone this global change. You'll notice that the object styles is heavily dependent on line weights and line patterns. Let's now take a look at how we can configure line weights and line patterns. To do this, on the Manage ribbon, we can select Additional Settings. In Additional Settings, let's begin with Line Patterns. In the Line Patterns dialog box, you can see that we have a number of default lines already configured for us. However, we can also create our own line patterns. So I'm going to go ahead here and create a line pattern for my parapet framing. So let's click New. Here I'll type in parapet framing, and now I can begin to define my line pattern. The line patterns can be comprised of dashes, dots or spaces. So I'm going to begin with a dash, and I want my first dash to be plotted on the screen at 1/8 of an inch. Then we'll follow that with a space, and a space would also be 1/8 of an inch. So that's my line pattern created. If I click OK, this is now going to be repeated, as you can see here. Those dimensions that I've specified there for the dash and the space relates to the printed output on sheet. So I can just go ahead and select OK to line patterns. Now, just so we can see that applied to this particular model, I can go back to my object styles. I can go and find structural framing, expand the subcategories, select my parapet framing, and now of course in here I can do a search for parapet framing, and there's my new line pattern that I've just created. If I click OK, everything's now updated. Now of course any subsequent changes I make to that line pattern will then update the entire project globally. So let's take a look at that. If I now go back to line patterns and I go ahead and find my parapet line type, let's edit this, and now I'm going to change this to 1/16. And we'll do the same for the space as well. And instantly you'll now see that the entire project updates. So any object style or visibility graphic override that's using that new line pattern will now update. Let's also look at line weights. Again, if I go to Manage Ribbon and Additional Settings, I can select line weights. Now here you'll notice we have 3 tabs across the top. The model line weights are referring to model elements. We have 16 possible line weights that we can apply, and then we have scales across the top. The Add button is to add new additional scales. If I select the annotation line weights, these aren't dependent on scale, and again we have 16 line weights. Of course I can come in here and configure these line weights to whatever I like. Let's go ahead and select OK. Finally, let's take a look at line styles. Select the Manage ribbon and then select Additional Settings, and then select Line Styles. In the line styles, you notice that we have again already configured a number of different line styles. We can clearly create new line styles down here if we want to. A line style will then have a name, a thickness for the projection, a colour, and a particular line pattern. An obvious one we can look at here is the line style for sketch. So you'll notice this is using pen 3 and magenta. So I'm going to change this. Let's make it red, and perhaps we'll get this using my new line style for the parapet. So what's now going to happen is this: if I now sketch something, for example if I go to structure and I select floor and I now produce a sketch, you'll see my sketched geometry is now using that edited line style. After completing this lesson, you'll be able to understand transfer project standards, transfer wall types, and transfer view templates. The objective domains covered are 2.1d, transfer system family files between projects, and 5.4a, transfer and review project standards. You can copy standards from one project to another with project standards. This is useful when transferring system family files and project settings that you may have used on previous projects to a new project. Some of the items that you can transfer are shown below: system family types, global parameters, line weights, materials, view templates and object styles, annotation styles, colour fill schemes and fill patterns, and print settings. Go ahead and open up the model 041 Transferring Project Standards. The model opens in a 3D view. In this particular model, you can see that we have a number of different system families set up. So here we have some basic wall styles already configured, as well as some ceilings, roofs, floors, and so on. Our intention here is to copy some of these wall styles from this project into a new project. So let's start by creating our new project. Click File, then New, and then Project. In the New Project dialog box, let's select Structural Template, and then click OK. So our new project has now been started. To begin the process of transferring project standards, select the Manage ribbon, and then select Transfer Project Standards. In the Select Items to Copy dialog box, you'll notice here that we could select the file that we're copying from. There are only 2 files open, so consequently we've only got one choice here, but of course we could have several models open in Revit. Therefore we'd need to select the correct one to copy from. What we're then seeing is the various different styles and standards listed in the dialog box. I'm going to begin by checking None, and then we'll select Wall Types. Let's go ahead and select OK. Here, Revit's detected that we've already got certain wall types set up, so I'm going to say here, New Only. Okay, so you can see that we've got some warnings down here. So Revit's just informing us that we've already got a family called MReveal Brick Course, so it's just renamed that to MReveal Brick Course 1. And of course we've got another warning in here as well about a conflict, but Revit will just rename those with a sequential number. So let's now take a look in our new project. If we open up the Families folder, and then we open up Walls, and then Basic Wall, we can now see all of those new styles of wall have been copied through. Next we transfer some view templates. On the Manage ribbon, again select Transfer Project Standards. In the Select Items to Copy dialog box, check None. And here we'll see View Templates. Let's go ahead and select OK. And again here you can see that we've got some duplicate types set up, but they are different. So in this case we're going to overwrite all of these types. OK, and now if we select View and View Templates, and we'll manage the View Templates, we can now see in the View Templates dialog box that we've successfully copied all of our view templates across into this active project. This can be very useful when previous projects have been created and you want to emulate the styles from that previous project. Go ahead and select OK. After completing this lesson, you'll be able to understand export settings, understand print settings, configure export settings, and configure print settings. The objective domains covered are 3.5a, configure export settings, and 3.5b, configure custom print setup. Revit supports the export of 2D and 3D data to other CAD systems. The following outputs are supported: DWG, which is AutoCAD format, DXF, Drawing Exchange format, DGN, which is Bentley MicroStation, SAT or ASYS, which is a 3D neutral file format, and finally IFC, which is Industry Foundation classes. When exporting to other CAD systems such as AutoCAD, you can configure how information and graphical data is transferred. For example, a common requirement in AutoCAD is the correct layering conventions. You can map Revit categories and subcategories to AutoCAD layers. Print settings can be saved and recalled for future sessions. Print settings control items such as paper size, for example, whether you want to use CD or E sheet sizes. The orientation of the print could be portrait or landscape. You may want to fit the page to 100% or half size scale, so you can use the zoom or scale options there. Hidden line views control whether vector or raster processing is utilized when printing. Vector processing improves performance, but sometimes we have to use raster processing if we've used things like graphics or rendered or shaded views. The options control whether things like crop boundaries, scope boxes or reference planes print. Go ahead and open up the model 042, configuring export and print settings. The model opens up in the ground floor plan. First, let's take a look at the Export DWG dialog box. To view this, let's select File, Export, Options, Export Setup DWG DXF. So the modified DWG DXF Export Setup dialog is now open. On the left hand side you can see that we can save or recall export setups that we may have configured. This is very useful if you have different standards and requirements for different clients. On the right hand side we have a number of different tabs to control various different elements of our DWG or DXF output. The most important one really is the layers, and you can see here that we have our categories and subcategories from Revit down here, and here we have our desired AutoCAD layer and our colour. There are other tabs across the top to control other elements. For example, we can take our line patterns in Revit and map those to corresponding line types in AutoCAD. We can do exactly the same thing with hatch patterns. The same with text fonts. We can configure how our colours transfer through. A very important one is solids. The default is to export 3D models out as polyface mesh. However, I think most of us would want ASYS or SAT solids. Another useful tab is units and coordinates. Here you can see the coordinate system base is set to project internal. Ideally, if you've used a shared coordinate system within Revit, you'd want to configure this to shared. Okay, so let's go ahead and create a new setup. So here I'm going to click New Export Setup. We'll call this one Training and then select OK. Let's begin by selecting the Layers tab. Now to begin the setup, you'll notice here we can load layers from standards, and I have some default standards set up. So I'm going to keep the American Institute of Architects standard current, and we can now make some modifications or changes to this. So we'll begin by taking a look at structural columns. So here we have our structural columns category. Notice if I click the plus button, I can see the subcategories underneath. And this is going to be the layer name that's used. So you can see here it's S cols. I'm going to change this to S columns. This is the projection pen we're going to be using. So I'm going to configure this to pen number 2. And you'll notice that everything here is under projection. We also need to deal with how elements are cut. Generally, we'll want to thicken the line weight up in AutoCAD. So therefore, we'll need to change the colour. So here we'll change the cut layer name to S columns. And then I'll have section afterwards. And we might want to thicken the line weight. So here I'm going to change this to pen number 5. Now, of course, I can go through and start to configure all of our subcategories as well. So we might simply want this to go on a layer called hidden, and we'll have all the hidden detail on the same layer. And that might use pen number 1. Now, this is great if we want to categorize all of our structural columns on the same layer, but sometimes we might want to split out things like steel columns or concrete columns, or perhaps have different layers for each level in the project. So this is where we can configure layer modifiers. To begin, we're going to minimize our model categories, annotation categories, and analytical categories. This allows us to have a smaller list in the dialog box. So under modifiers, you'll notice here we have material for model behavior. Let's expand that. And you can see here we have all of our material for model behavior settings. So concrete, other, precast, and so on. So I'm going to change this. Perhaps we'll just have conc for concrete. And we'll do the same for the cut. And for steel, we'll have the full name, but in capitals. Okay, so now we'll go back and expand model categories, return back to our structural column category. And of course here we can add or edit our layer modifiers. By default, the layer name is just built up out of structural columns, but this is where we can add our modifier. So here I'm going to add material for model behavior, and we'll add that across. I'd like to have a hyphen as a separator in here, And now that's complete, so we can click OK. And of course, I can now proceed through the rest of my categories. This could take some time to configure, but don't forget you can save these setups and utilize them later. Okay, let's now export a DWG file and review our settings. Go ahead and select OK to the dialog box. Click File, then Export, CAD Formats, DWG. Notice in the top left of the DWG export dialog box, the export setup is training. We're going to simply export the current view as it is at the minute. We'll click Next, and we'll go ahead and save this. Okay, so once the model's open in AutoCAD, let's go ahead and review our layer settings. So if we zoom up on one of the columns that we created here, let's select the column, and on the home ribbon here, you can see that we have S columns concrete. Let's have a look at one of our steel columns. So here's a steel column. We can select that. And of course, we can now see that this one is being exported to S columns steel. Here we have our plan position of a steel column and also our cut position of a steel column in section. Next, we take a look at the Print Setup dialog box. Select File, and then go to Print and select Print Setup. In the Print Setup dialog box, you can configure your paper size, your paper placement, whether we're centering the plot or perhaps offsetting it, whether we're going to zoom to fit on the page or in fact print it at 100%, the orientation. Here we can select hidden line views. So most of my views are vector, so I'll use vector processing as this will increase performance. And when we are printing raster files, we can configure our raster quality here. So in this case, because I haven't got any of the rendered models in the file, I'll use medium. Now of course, if I want to print out monochrome, I can do this. I can select black lines only in here. And in the bottom half of the dialog box, I can configure exactly what plots. So most of the time, we're going to want to be hiding things like the crop boundary, reference planes, scope boxes, and so on. Once we've configured this, we can save as, and we can give this a new name. So here, I'm going to call this training and select OK. When we now configure a print, you'll now notice that we can choose our setup. So currently it's the last one we've just configured, which is training. Okay, in this case, let's cancel the dialog box. Our print setups are complete.